So hello, this second part of our video will cover basically our calculation of current. So the first part was obviously impedance. We solve for impedance. So when you do these always solve for impedance first. Then you solve for the current or voltage, but most of the time you'll be solving for current. Okay, so this thing goes in order, right? Like we did equivalent resistance, you get our resistance, then we get our current, right? Our current is our basic principle because voltage always stays the same. I mean, it really doesn't change that much unless you drop it over in the impedance. But here, current is going to change. And so our current calculation here, and I'm going to write this down, our current is going to be solved in this following manner. Okay? What we would understand current is that I is V over R. In this case is what? Z, because we have impedance. So we have V over Z. Okay? Now, what is our V over Z? How do we analyze V over Z? So we have I is equal to what? V is 120 at 10 degrees, and this is divided by here, our Z, right, which is 100 plus J, 113.04. So that's 100 plus J, 113.04. Okay, so what we have is two different forms. What we have is right now is we have polar form, and I'll just make a note of this, okay? Put a note on the side. Polar over Cartesian, and I put cart, but this is just short for Cartesian. What we want is polar to over polar. Now, refer to other videos for Cartesian to polar, polar Cartesian, but in reality, it's polar over polar. So because polar, you can multiply and divide in polar, and addition and subtraction is occurred in Cartesian. So what we have to do now is convert the bottom from Cartesian to polar, while the top will remain as polar. So we want to convert Cartesian to polar. Okay. Why do we call it current? So now what we want to do is convert this 100J 113.04 to its polar form. How do we do the conversion in its polar form? Okay, this is not very, actually it's pretty simple really when you do it. Let me move this mouse away so that I can, you can see the problem. Okay, so the polar form here is a simple conversion of Z equivalents. Okay, so Z becomes equivalent. So what do we do? Well, it's simply the Pythagorean theorem. And here, understand that this is 100 squared, and this is the second part. You skip the J. You skip the J. 113 point, and then this is, what I do is I have a little stylistic thing where I bring down that so I know where it ends. Okay, it's kind of a stylistic thing for me. But here, okay, and this is the square root. So our Z is equal to what? Our Z is, we simply take our calculator, 100 squared, which is we get what? 10,000 plus 113.04 squared, which is 12778, right? And we're just going to put 12778.04. Okay. That placeholder is not as critical. I'll just keep it to the second placeholder. Okay. Plus 10,000. Okay. You take the square root, you get 150. Okay. And we're going to do this again. I want to make sure this is right because I'm not sure if I'm getting the right answer. Plus 12778 plus square root, I get 150. Okay. So Z is now 150.92. Now, why don't I go to 151? Because there's a level of accuracy here, and I just maintain at 2 decimals at most, right? So because the number is kind of short. So the next thing you want to do is you want to be able to get the angle. So here you got your magnitude, and now you want to get your angle. So your angle is simply is arctan, okay, and that is that's right here, this value right here, 113.04 divided by what? 100. and you're going to get this point value. You're going to get the value 113.04 divided by 100. And you get this value 1.13, and you simply take the second tangent. So I take the second tangent here. I get arctan is 48.5 degrees. Make sure this is in degrees and not radians. Okay, so if you kind of look at it very carefully, it's in degrees. Okay, 48.5 angle. Now, if you get radians, you need to convert on your own calculator between degrees and radians. Okay, so here's our current. So our current value is finally, okay. So our Z equivalent is now. So I didn't get my current value yet. My Z equivalent is now in polar form, which is 150.92 at an angle of 48.5. And let me rewrite this. This is really messy. Okay, and so I is now V over Z, which is what? Our V is 120 at 10, and our Z is 150.92 at an angle of 48.5. Okay? Now, how do we solve this? Well, the polar is very simple. Polar makes life a lot easier. You simply divide this and you subtract this. Okay? So we're going to get a division of 120 over divided by 150.92. 120 divided by 150.92, which you get 0.779 or 0.8. So we get 0.795. And what's our angle? Our angle is 10 minus 48.5. So that's 10 minus 48.5 degrees, which will leave us a current of 0.795 at an angle of 10 minus, okay, 48.5, which is minus 38.5. Okay, and you leave the angle negative, even though it's coming off the 360 this way. You leave the angle negative, and that's your amp value. Okay, so part 3 of the video will consist of power factor and power and all these other calculations, which I will show you. So from here, this is, you would call this page 1, right? So we will call this 1 here. We'll call this page 2 here, right? And we will refer to both pages when we do our power calculation.